All right, thanks, Jay. Thanks, everyone, for coming. And yeah, so it has been said several times, but I'll say it again. What I'm really excited about today is listen to your feedback, help us shape what the future of this project looks like. And that's what today is really all about. And before I start, I'd like to say hi to Alok. I don't know where the video is, but Alok couldn't make it today, so he's here in spirit. All right, so before I get started, it's difficult to talk about Hack without talking about PHP. And so I picked a random PHP developer. You might have recognized him. And he was trying to build something, right? Back then in 2004, he was trying to build something called the Facebook. And he picked a technology to do that was PHP. And we think that it has been a really good choice because PHP is something that allows you to iterate very quickly. And this is what we often call here the fast feedback loop. So what it means is that you write a piece of code and instantly, when refreshing your browser, you can see what effect it had. And from there on, if you're trying to build an experience like what the Facebook was, what we can do is adjust and carry on iterating until you find the experience perfect. So now, I picked another programmer who is living in a different world, and I chose C++, but really I could have chosen any other statically typed language. And this world is very different. And what they're trying to do in this world is, for C++ specifically, what they're interested in is squeeze out as much CPU as they can out of the machine. And it's a valuable goal, but it's a different goal than a PHP developer. And if you look at the stack is very different, and the process, the feedback loop that you have in PHP is much slower. So if you look at this process, there's compilation step, linking step, etc., etc. And so the problem is, I mean, that's not a problem. If you look at static typing, there are actually many good things that come from this world. A lot of tooling. So for example, you can catch errors early. You get a lot of tooling, especially in Java, for example. A lot of things can be done automatically for you, right? And so what we tried to do with Hack was bring the best of this world in this world. Now the problem is, if you're going to do that, you really want to be careful and not break what made PHP a good choice in the first place, right? So you don't want to break the fast feedback loop. And so I'm going to start a demo so that you guys can see what I'm talking about. All right, is that on? All right. So this is very simple demo. I just want to show what hack code looks like. So a hack file starts with $HH. And I'm going to write a very simple function. Don't try to guess what the meaning of this function is. There is none. I'm just trying to introduce a simple error in the code. So here you notice that I wrote column int, and that is the syntax to declare the return type of a function. So here I'm going to return a string instead of an integer. So I save the file. And now I have a compilation step, sort of, that looks like what you would see in the static world, and the compilation step consists in running hhclient. So I run hhclient, and I get an error. And what you could do is try to demangle that error, look at the line numbers, open the files, figure this out. I strongly recommend you don't do that. We have plugins for all sorts of editors, whether it's Vim, Emacs, and if it's missing, we'll probably want to build it anyway. So what I strongly recommend you do is you integrate Hack into your workflow and you run it directly from your editor. So in this case, it allows me to navigate. So a couple of words about the Hack errors, because Hack errors are a bit, they're trying to tell you a story. So the first line of the error message is the nature of the problem. So in this case, the nature of the problem is this is an invalid return type, and it points you to the place where the invalid return type was detected. then the rest of the message is explaining, is giving you hints on how to fix the problem. So in this case, it's telling you this is an int, and this is incompatible with a string. So I'll go again. The way you read this is first you go where the error is. Once you understand that there is an error, you navigate to see what part of the code you should be fixing to fix the problem. That's what it's about. So I'm going to remove this file, run client again, everything is clean, and go back to my slides. All right. So now we've seen very briefly what this thing looks like, and what I would like to explain briefly is what is hack, basically. So I'm going to start and taking all these bullet points in order. So hack is a statically typed language for HHVM. What that means is that there's a type system that runs ahead of time before you run the program, and that catches typing errors for you. It is compatible with PHP. What that means is that you can call hack from PHP and call PHP from hack without any overhead, without any stub code, without any magic incantation. It just works, right? The same representation at runtime is actually very important, because if you're building something like an object, you want a hack object to be compatible with the code that you have in PHP. It evolved from PHP, and that's important because what we tried very hard to do was for you guys and for the engineers at Facebook to have one mental model. So what is dangerous is to have a code base where you're mixing hack code and PHP code, and the hack code is different in very subtle ways. So you're running your code and you think you know what it's doing, but really there's a subtle difference. And we didn't want any of that. So we made sure that the behavior that you see is not going to be surprising. If you know PHP, you know hack. This is what it means. Finally, it has been designed for incremental adoption, and I'll show some of that later. But it's encouraged not to try to convert everything at once. What I think is a better workflow is to start small, start with one file, see how you like it, see how you adjust to it, and then grow incrementally. That's what we did internally. That's what it was designed for. And so feel free to do that. Okay, so I showed a return type earlier that was column int. There is a pretty rich type system. So I'm not going to go through all these. For example, there's a talk on collection later that is going to be pretty awesome, and that will explain that in details. The only types that I'm going to mention specifically is the nullable type. And nullable is basically in hack, you have to say specifically when something can be null. And that's because when something can be null, it can have surprising behaviors, like it can convert silently to something that wasn't expected. There's mixed. I'm not going to say much about it, except that it's basically a type that is super type of anything else, and it will be important in the rest of the presentation. So that's for the type system. How much work do you actually have to do, right? Let's say you want to get started tomorrow. You want to open your editor and start hacking in hack. Well, this is what you have to do. You have to add type annotations in 3 places: on class members, function parameters, and return types. And that's it. And all the rest is inferred. So inferred basically means that you don't have to add an annotation. The type checker will guess what this type should be. So if you write $x equal a string literal, you don't have to say that $x is a string, because the type checker is going to pick it up. It's going to infer it. That's what inference means. So I need to mention these modes, and it's because these modes are going to be important for the conversion talk that is coming next, that Josh will talk about. And there are different modes of strictness in hack, depending on how flexible you want it to be or how strict you want it to be. So strict, I will introduce that later, is very strict. Everything has to be in hack, everything has to be annotated, everything has to be checked. The default is partial, that we call partial, but really you just have to say $HH, and that means check as much as you can. And if there are things that you don't know about, well, don't complain and just assume it's correct. And the minimum, the minimum is decal, and decal means don't check anything. I just want you to know that this PHP code exists. That's all what I care about. But I don't want errors on that code. So I'm going to make a second demo that this time tries to showcase what conversion looks like. So I have a little PHP file here. So it's nothing very complicated, right? So it's just a very, very simple data structure. That's a mailbox, and you can send a message to the mailbox or fetch a message from the mailbox. So as I said earlier, every file starts with HH. And so I save the file, I run the type checker, and it says no errors. And that's going to happen pretty often. It's going to happen pretty often that you have a PHP file and it just happens to be valid hack code. It won't always happen because there are certain features that are not supported on purpose, but it will happen often. And so let's try to start annotating this code with annotations. So here I'm going to say this is a string. This looks like it's taking a string. And actually, I could stop here. I could stop here and say, okay, I have done enough on this file. I've done enough work. I'm busy. I want to carry on annotating later. And then if you choose to do that, then the parts where you are already going to get some checks, right? So if you try to use the mailbox that we have with the wrong type and that part of the code is annotated, you already have some value there. You already get some errors. So for this demo, I'm just going to finish annotating all here. Okay. So now I think I'm done. And the next question that comes to mind is, am I done? Right? You look at this file and you're like, great, it looks like I have added all the annotations, and now I want to know what is checked and what isn't. And there's really no good way to do that, so I'm going to show you a mode that we have that is called --color. So --color shows you the content of the file, of a file, and tells you in red which parts are not checked. So in this case, send is not checked, and that was not meant to be in the demo. It's because I forgot to say void. All right, so now let's go back. So this tool is actually useful. So basically, the part in green means the type checker knows about it, and you have static guarantees on this. The parts in red mean, I don't know anything about this, you are on your own. So in this case, I've added a PHP function call where a PHP function is some function that is defined somewhere in PHP. So what I could do, I have several options here. So first I need to show you strict. So another thing that you can do if you don't want to go through this coloring mode and you want to know for sure that everything in your file is checked, what you do is you use the strict mode I was talking about earlier. And strict will not allow you to use a PHP function like this in the middle of nowhere, right? So in this case, I'm just going to remove this function call because it was just there for the demo. So now, earlier I said that there was a nullable type and that this nullable type was very important. If you look at data here, I initialized it with an empty string. And normally we don't do that. What we do normally is we use null. So I want to show you how you adapt your code to make that work with null. So now you go to this annotation and it says wrong type int. I was expecting a question mark string. So now this fixes the problem because I'm telling the type checker that a string can be null. I carry on. It's complaining here now. and now it's complaining here. And I could go on like this forever. I could add question mark string everywhere. But that's not very useful. At some point, you really want to use that thing as a string, right? And the way you do that is by checking that the string is not null. So you're going to write a piece of code that looks like this. And within this branch, because I checked that $MSG was not null, the type checker picks that up and lets you use within the if statement $MSG as a string. So in this case, if I return $MSG, this is going to work. So here I need to return a default value. And this works, right? As expected. Okay, so I've shown you what a nullable looks like. If you look at this mailbox, it could actually work with any type. I've chosen the type string, but really send and fetch could be sending or fetching any data. And so what you can do is use generics. So they're called generics or templates, or depending which programming language you come from. But the idea roughly is that in this case, I want my mailbox to work with any kind of type, and that's the syntax to introduce that kind of type. So here I'm going to go ahead and replace my strings with T. And this works, right? So what is interesting is I didn't have to write string here, like some languages would force you to do that. The string, the fact that it's a mailbox of string has been picked up, it has been inferred by the type checker. So you don't have to write it. And when you use generics, so let's say I introduce an error here, the error message system that I showed earlier is very handy, because not only does it show you where the error is, and it will point you where it deduced that something has a certain type. So in this case, it's going to point you to the place where it deduced that mailbox was in fact a mailbox of string, so that you don't have to demangle your code. Because if this wasn't a string literal, if this was a function call, looking at the code, it might not be obvious. And you might be looking at this thing thinking, well, where does this string come from, right? And so this witness system will point you where it was deduced. So I'm just going to fix the error here and close that guy for now and go back to my presentation very briefly. All right, so up until now, really what I've shown you is a statically typed language, right? That kind of interacts in some interesting way with PHP, that is well suited for PHP and for incremental adoption. But really all what I've shown you is this world. And the legitimate question is, okay, but how is that different from Java? I chose PHP in the first place. You're showing me something that really very much looks like C# or Java. So why do I care about this stuff? Why I didn't pick up Java to begin with. Why would I pick up a hack? All what you're showing me is stuff that I already know about, and I have chosen not to use. And I could try to explain with words, really, that there's this fast feedback loop that we try to preserve as much as possible, but I really can't. I just have to show you what I mean by preserving the PHP workflow. So here I created a directory called large, and in this directory I created thousands of files, right? So I'm going to ls through these files and count how many there are. So there are 1,000 of example files. These files don't do much. All what they do is just for the demo. What they do is they make a function call. They make a method call to a method called bar. That's all what's happening here, all right? So I go where the method is defined, and I'm going to introduce a typing error. And that's what I want to show you. I got 7,000 lines of errors absolutely instantly. Now I'm going to go ahead, fix the problem, and actually measure how long this took. And in 160 milliseconds, I got back my result absolutely instantly. So why does this changes everything? Because now you can put the type checker in your workflow, in your editor, right when you're saving, you can hit that key as often as you want, and it will just work. Now, let's go a bit further. And I introduced the error back, and I created a branch called remove examples that takes all these files and just removes them, right? So I'm going to go ahead and check out this branch and run the type checker. Boom. And that's important too, right? Because you're using Git, you have many branches, you need to switch environments, you need to run scripts, etc., etc. And so you want this workflow to be fast and responsive. So here, if I go back and measure how long it took, you could see that I checked out the branch, I modified 1,000 files, that's Git that did it for me, and I run the type checker, and it was right there in my workflow. All right, so now I'm going to fix that error. All right, it's fixed, and show you a couple of other things. So if I look, if I look at the list of option accessible in on this command line tool, you can see there are some interesting ones. So I'm going to go ahead and show you that one, find refs. So that's something that is useful to find all the places where a method is used. So I'm going to go ahead and try to find all the places where, so that only includes hack code, of course, right? It won't find the usage in PHP code. So here, because I had my bunch of example files, it just shows me the 1,000 places where the function bar is called. And if you look closer, you can see things like this one. This one is interesting, right? And if you look at these options, you probably see where we're going with this, right? So I don't want to spoil anything because there's a surprise presentation at the end of the day. But all what I'm going to do is open my browser and just start typing a very simple, thing, and let you guess what the surprise presentation at the end of the day is about. So let's close this. Let's not spoil it. All right. So we're back to this. And back to the presentation. All right. So in this first part of the talk, I have been mostly talking about Hack and how to use it and how this can help you in your workflow, hopefully. The rest of this talk is really going under the hood. So I'm really going to get deep into the technical details of how this thing works, really, right? So there are two parts, one on the type system, the other one on the architecture. And I'm going to start with the type system. So PHP was not designed to be statically typed. And so one of the challenges of Hack, of this project, was to retrofit a static, a type checker, a type system within the language. And I picked one example that makes that difficult. In this case, I showed you a pattern that is very common among PHP developers. They write an if statement, and in this case, they define $x in both branches of this if statement. And in PHP, you would expect that at this point, $x is defined, and it's an integer, and it's fine to use it. Now, most statically typed languages don't work that way. What they do is they have something called lexical scoping, and they force you to introduce the variable, and sometimes even force you to give the type of this variable. So we had to support this, among other things, because if we don't support this, well, then there's just too much code to rewrite, and it's not really what we wanted to do. So now, it looks simple, right? You think about it, you're like, well, okay, just look at the left branch, look at the right branch. If you see $x in both branches and they're both integers, well, just deduce it's an int. Simple algorithm, right? But I want to show you something else. I picked the same pattern with different types this time. So they're not ints, they're objects. One is an A, the other one is a B. And A and B may have a common ancestor, but they may have multiple common ancestors. And when that happens, when you get here, you're like, well, what's the type of $x, right? because if they have 5 interfaces in common, it could be any of these interfaces, right? So before I go through the details of the solution to that problem, I need to introduce a bit how a type checker normally works. So if there are type theory purists in the room, it's a very, very simplified version of what's really going on. It's not meant to be accurate, it's just to give a sense of what's going on. So what would normally happen is this. So you would take the code, you would take $x in the first branch, and you would unify $x with A. Unify is just a fancy word to say that we now know that $x is of type A. And then the type checker would carry on and see $x equal new B, and deduce that, well, it has to be a B as well, and it would give you an error. It would say, well, it can't be both an A and a B, so I'm just going to stop here and say, well, I don't know what the type of $x is. So the solution in Hack is to use unresolved types. So what that means is that when we see $x equal new A, instead of saying $x is an A now, we're going to say $x is an unresolved A. And what that means concretely is that $x is of type we don't know what it is yet, but we know it can be an A. Now you do the same thing with the other branch, which is new B, right? And so what you deduce now is that $x, I don't know what it is yet, but I know it can be an A, or I know it can be a B, right? And so in a way, with this unresolved type, we are delaying the moment where we deduce the real type of $x. And the moment where we deduce it is when there is a function call or some kind of annotation where you specifically said what you meant. So in this case, I have takes an interface, which is a function that is has an annotation with a type annotation that says iFace. And when I call this function with $x, that's the moment where I'm going to check that both A and B are subtype of iFace, and that's the moment where I'm going to deduce that $x is in fact an iFace. Now, this mechanism can lead to surprising results. So here's an example of surprising results, right? And when you write this code, you have a mental, so vector is a collection type. There'll be a talk about this later, but you can see it as an array, okay? So when you see this code, $v called vector of 0, 1, 2, 3, you have a mental model that says, this is a vector of int, of course, right? It's a vector and only has integers in it. And then I add a string to it, and Hack is not complaining. And when you write the code, you're like, well, why does it let me add a string to something that is obviously a vector of ints, right? It's because it is not a vector of int. It is a vector of unresolved type that can be an int. And so past this second line, the type of $v is, it is a vector of a type that can contain strings or can contain integers. Now, it doesn't, and the reason why this code is legitimate is because of this, right? I said earlier that there was a type called mixed, and mixed could be anything. And so when you see these two lines of code, if the programmer was trying to build a vector of mixed, then this code is perfectly legit. Why would I, prevent him or her to add a string to a vector of mixed? And at the end of the day, it doesn't matter, because unless you're writing a toy example, the moment where you really want to use it as a vector of int, that's the moment where it's going to complain. So here, I am building a vector of ints and strings, and then I am specifically writing down that I am returning a vector of int, and that's the moment where you get an error. And on top of that, not only do you get an error that points you to the place where it was deduced that this vector had a string in it. So, and that's why the error messages are important, because the system that infers the type, the system that checks the type, is complex. There is complexity there. But what we can't afford is for for you guys to have to understand this system. This doesn't work, right? You can't expect everybody to think about unresolved types in their head while they're trying to write code. And that's why the error message, the error system is really important. So now, the architecture. So the architecture is interesting because it is structured in a way that is very different from what you would see in a normal programming language. I was going to talk about the history, but I think I'm going to jump directly to HHVM. And so what we built a couple of years ago is something called HHVM. It's a JIT compiler for PHP. What that means is that there's no compilation cycle. You take your PHP, and exactly like in any other dynamic language, this PHP is translated on the fly to native code, and then this native code runs, right? And on the fly is important because it means that you don't have to wait. You write your code, you press refresh, it just works. Now, recently what we did is that HHVM now supports both languages, Hack and PHP. And what I want to stress today is that HHVM is still a PHP runtime, and it's going to be that way for a very, very long time. In fact, what we are doing is investing more resources to make HHVM a drop-in replacement for PHP 5. So we're not going away from PHP. At the contrary, we're investing more resources to make sure that it's compatible with your code. There will be a presentation about this today, and there's a team behind it that takes any incompatibility issue that you may have very seriously. All right. So what does a traditional architecture look like? So here I picked again the C++ model, but really there are many different models. Basically, and they all boil down more or less to that. You have a binary that is called a compiler that takes an input file and produces .o files or object files, and then you have some kind of makefile system. Sometimes this makefile system is integrated in the compiler, and then a link step, and then tooling. And when there is an IDE, traditionally the architecture is that the compiler lives on one hand, the IDE on another. And they either talk to each other through some way, or the IDE tries to re-implement heuristics that are trying to approximate what the compiler is doing in terms of type checking, to know what the type of things are, for example. And this design, when you think about it, is a bit strange, right? Where you have the compiler that is doing type checking, you have the IDE that needs this information, and somehow they're still separate things. And the reason why they're separate is because they came to be at different times. So compilers and the traditional architecture around compilers were defined much earlier, much earlier, and IDEs came back very late in that game. And so for historical reasons, that's the design that traditionally people use. Now for Hack, we wanted these two things to be the same thing. So we knew from day one that what we really wanted was to be highly integrated in the tooling. So whether it's Vim or Emacs, what we wanted was whenever you save a file, be right there, right? And so that's why the type checker itself has been designed like a server. Another important thing that I didn't say is that it's supposed to scale. So Facebook has a huge PHP code base, tens of millions of lines of code, and we needed to make sure that all of that was working smoothly at this kind of scale. So the solution was to build a server. And so the server really works like a daemon that you start, that takes your root directory and basically gets all the information about your PHP files. And once the server is up, so at the beginning it tracks dependencies as well to know what method depends on what, etc., etc. And it recomputes automatically when you change a file. So it's not, when I called HH client, nothing happens, right? Where the magic happens is when you save the file. Because the server, the daemon, is listening to the kernel events and updating the state of the world in the background. And that's why as well, when I'm running Git, and Git is going from one branch to another, without you having to do anything, the daemon picks up the changes in the background and makes sure that when you're calling HH client, everything is up to date. So the constraints. We needed a low latency, and that was very, very, very important for internal adoption. I'm going to say it again, I said it multiple times, what matters with PHP is refresh browser, it has to work now. And if you want to be in the way of that workflow, you have to be extremely responsive. So we set really aggressive goals on the latency. Less than 200 milliseconds on any given change that you could do in an everyday operation, and less than a few seconds if you are doing a huge operation on Git. But this is at our scale. I doubt very much you'll get to a couple of seconds. It has to work with revision control. So I showed that earlier. There's Git, there's Mercurial, there are other tools. But we really wanted this to be smooth. And then the classics. It has to use, a reasonable amount of RAM. The initialization time cannot be 12 hours because people are not that patient. And it must be stable. And the stable part, I think we have done all the groundwork internally to make sure that that this thing is stable now. There will be problems. I'm sure there will be problems. But most of the groundwork has been done internally. So now there are three things that we really did to make sure that the server was always responsive. First, we parallelize a lot of things. So we have machines with many cores. The more cores, the better. And one key solution to make things fast is to make sure you're doing a lot of things in parallel. Another important trick is to cache. So don't try to recompute twice the same thing. As much as you can, try to reuse something that you already had in memory. Finally, we do things incrementally, and what is important is to be very fine-grained. If whenever you change the file, you go and recheck everything that depends on that file, that's not fine-grained enough. You want to be at a level where when you change a method, well, in fact, if you change the return type of a method, you know what to recheck based on that return type. You're not going to recheck the entire world. So, a couple of graphics showing what's going on. When you start the server for the first time, it takes your root directory and basically does all these things. It populates the caches. Basically what it does is that it keeps a version of things, of the types, of the trees that it needs to do the computation. It does all the checks and computes all the dependencies. So I have a slide later on about the dependencies, but the way this works under the hood is that while we're doing the checks, what we're really doing is recording dependencies. So while I'm checking the function foo, and function foo uses bar, I don't have to explicitly write somewhere, remember that you're using bar. There's a system, there's a layer of abstraction that keeps track of that. And that's important because we need to know what depends on what at any given time. Now the second part of this architecture is that all this is communicating through a shared memory model that is nasty lock-free C code. Don't get into that if you have a chance. And basically that's the way they communicate. It's important to communicate that way because the way you communicate between the different processes is going to be very important for the kind of latency you're shooting for. So now concretely, you just modified the file foo.php. What is really happening? So step one, we take everything we knew about foo.php and we stash it, a bit like git stash. So you take what you have and you keep a version of it somewhere. You don't erase that, you don't delete that information. Then we take this file and we compute the new version of foo.php. Once we have that, we take the old version and the new version and we compare the two at a very fine-grained level. So we know if the only thing that changed was a return type. Let's say you don't change the signature of anything, well, we know we don't have to recompute anything because the signatures are the same. And so once you have this mechanism to compare the two versions, you can deduce, thanks to the graph of dependency, a very fine grain what needs to be recomputed. And this is what makes it fast. So I said earlier I had a slide about this, but basically I ended up explaining about this while I was talking. A few more words about this is basically that's the mechanism that keeps track of all the dependencies and how this mechanism works. It's interesting if you want to dig into the code, but I won't say much more about this. So I think that gives you a good picture of what's going on under the hood. If you want to know more, feel free to reach out. That's what I'm here for today. And that's it for me. I have plenty of time for questions, I hope. And that's where you get started. Everything should be on the website. Thank you.
I've lost my microphone. We do have some time now before the break, though, so 10 minutes or so for Q&A. And we're going to try and have Q&A at the end of each session whilst the speakers are up and kind of the topics are hot in your mind. And I know we have, I think now, over 1,000 people on the live stream. So same applies for folks on the live stream. If you have a question that you'd like to ask Julien or any of the team, just pop it in the chat there and Joel will moderate. But let's start off with anyone in the room. Raise your hands. We have mic runners in the corner who will bring you a mic. Yep, one in the middle.
I'll take some water, sorry.
Yeah, are there certain PHP techniques that you should kind of like shy away from?
That's an excellent question. I should have mentioned some of that. Techniques is maybe a strong word. Let's put it that way. There are some dynamic features that makes the type checking a bit out of reach. However, I don't think it's a non-goal to end up in a world where everything is statically typed. So what you can do is leave some parts of your code base dynamic if you think that's suitable. There are some, so techniques I don't know, but there are some features that are not going to play nicely with the type checker. Now, there will be a lot more about this today, so Drew is going to talk a lot more about this.
It's probably been asked before, but I was curious why HHVM, why not run on the JVM, like some of the other languages chose to?
Right. So I guess because the JVM we would have had to, if we wanted to have this kind of fast feedback loop on the JVM, I don't know. I'm not an expert, so I don't know how much work that would be. And for us internally, we have been very successful with PHP, and what we're trying to do was make the experienced developers more productive in our environment. So frankly, I don't know. I don't have a good answer because I don't have a feel of how much work this would be to target the JVM.
Actually, we have a session this afternoon that Edwin's going to be giving, and he's actually asked that if you ask that question again, he'll be able to go into it in a little more detail.
Oh, the question was, why didn't we build HHVM on top of the JVM? That's your question? Oh, okay, I see. So that's a perfect question for this guy. Now I understand. I thought you were asking me why don't I take hack code and compile it down to the JVM, and then I was wondering. So yeah, that's a question for Ed. He has all the answers to that.
What's the breakdown between what happens for the hack compilation, the type checking between the server and the client? Is code sent over, or is the chain sent over, or is an abstract syntax tree or type system kept on both sides? How does that work out?
Excellent question. So HH client doesn't send anything. All it sends is a ping that says, what's the state of the well? And the clients and the server don't really communicate with each other than error messages. Where all the information, the server, the daemon, directly talks to the file system and the kernel. So it's watching all the changes on the files, and it talks directly to the kernel. So HH client doesn't have to say what changed, because the daemon already knows through the kernel what has changed, right? And that's not the communication channel we use. Between HH client and HH server, not much is happening other than ping, what's the state of the world, please tell me.
Does the type checker show errors over here?
Oh, okay, sorry.
Does it show errors that you would see sort of typical with the PHP linters, so syntax errors, fatal errors, those kinds of things too?
Yeah, so it doesn't show all of them. The set is slightly different, but yes, there are many errors that where the nature of the error has nothing to do with types. So like syntax errors, there are many others. Yes, it's true that I've mostly shown typing errors, but there are other kinds of errors that are covered by the type checker, yes.
We had one in the middle there.
Is there a particular version of PHP you plan to be compatible with going forward?
Yeah, PHP 5. That's a question for Sarah.
5.any?
Actually, Sarah, do you want to take this?
So we're currently kind of counting ourselves compatible with 5.4. Our target for the moment is 5.5. We have a couple of features that we need to pull in, but we plan to just continue to track each version as they come out.
Yes, is there a feature for hack outside the loop, the F5 loop in the desktop?
I'm not following, sorry.
That is there any feature for hack like C# in the desktop?
Oh, in the desktop world?
Yes.
That's a good question. I hope there is. I don't really know right now. Right now we are focusing on the things that we know work. Do we want to expand and build more tools around desktop? Maybe. Well, maybe you can start the project if you want. I'll be happy to help you. So I don't really know. Right now, this is not the main focus, but certainly it's an option.
Does hack introduce any drawbacks, or is it pure awesomeness at this point?
Okay, do you want an honest answer, or do you want absolutely not? This stuff is awesome, right? I think, yes, there is a drawback right now, which is it's too awesome. That's the problem. No, the problem is it's still young, and there's a risk. And I think for everybody in this room, when you engage with this technology right now, it's true that you will hear some of that. Some people who are saying, well, it's still a young technology. And when you embrace a young technology, it comes with a risk. And I appreciate all the people who are, putting their best foot forward and willing to take that risk with us. I think that's the main thing right now, right? So using hack or working on hack? On hack, even that is hard to tell because it's a cross-team effort, and then it really depends how you count. So all the people who are talking today are heavily involved and are core contributors to the project. But I think, to be fair, there are plenty of people in other teams who contribute in many other ways. So I'd say core contributors 5, 6. Then beyond that first circle of core contributors, where it can go to 20, 30, depends how you count.
I think what you said about risk is important, but more along the lines of if I'm going to take the time to educate my team and the people that they know about working on hack, it's not so much a risk of them getting pumped and committed to doing it. Like if we're going in the direction we're going to do it, it's more of a risk in my eyes about Facebook saying, we're not really feeling hack now. We're going to change it to schmack or whatever it becomes. You know what I mean?
Actually, it's coming up. Yeah.
How likely are you guys to continue this as the standard internally and externally?
So I think I'm obviously going to say fully committed, right? I don't have any other option. But let me say a few words about this. So at the beginning of the talk, Jay came on stage and say very important things, such as, yes, we used to not be careful enough in the way we were dealing with open source projects, and we're really working on that very hard. So James is doing all the work he can to make sure that the open source projects that we put out there, we are dedicated to them, we take pull requests, we read, we talk, we have forums, we have IRC rooms, we make sure that we show dedication. Now, I think what you're showing is healthy skepticism, right? You're like, okay, you guys just started, and I don't know where you're going to be in 2 years. And I think we have no other option. I could talk about this for 2 hours, but we have no other option than just show dedication. So our only option right now is be there, listen to you guys. Whenever there's a bug, go fix it, talk to you, build things together. And I think that if we deliver, and if we really carry on building that trust, eventually there will be trust. That's how it worked for us internally, where, you know, this skepticism happened internally too. There were people who were saying, well, so how long are you going to work on this thing exactly, and how real is this thing? And the only way to overcome these kind of fears is to show dedication. And this trust is going to build over time, I hope.
We have a session after the break where Josh is going to talk about how we've upgraded or converted our internal code base. You know, it's worth stressing that every developer at Facebook who was previously a PHP developer is now a Hack developer. So, you know, we have a user base of however many thousands of people that is already. So we have a very strong commitment that we have to hold ourselves to.
Hi. Are there any current projects to use Hack and the HHVM machine as its own framework, like Ruby on Rails, or to enhance other PHP-based frameworks like Laravel and Symfony?
So I'll let Josh take that question. Where's Josh? He's over there. Because he has much more context on this.
I don't know how much more context on this I actually have. Like directly contributing to Symfony or Laravel or something, that's not something we're probably doing in the immediate future other than bug fixes that prevent them from working on HHVM well. As far as general enhancements to the PHP ecosystem, I think Drew and Eugene are going to mention that we are starting to think about rearranging the PHP standard library. There's a lot of problems in the standard library that they'll go into. That's probably the closest to what you're asking that we're planning on in the near-term future.
Oh, and Paul wants to say something.
As a quick addendum, there is 2 people in the audience, Simon and Atch here. Yay, there they are. They have built a Hack-only framework. So it only works on Hack. It's called Beatbox. It's actually kind of cool.
So I think that's what the question was originally. Yes, thank you for bringing that up, and thanks, guys. It's awesome. Fred? Okay, everybody wants to answer that question.
So the other problem is that most of the popular frameworks want to support really old versions of PHP, like they still support PHP 5.3. We have trouble at the moment working out how we can support Hack type interfaces and still run on a 5-year-old version.
So we're not here to talk about the problems, Fred. Thank you very much.
I had one other question. I'm sure it comes up, you know, like if you want to use libraries that are written in other languages, so how does, you know, Hack support interop with other languages?
So you mean other languages other than PHP?
Other than PHP, like if you have to use libraries from Java or Clojure or Scala, what do you do?
You are not in good shape. I mean, what you have to do is basically what you would normally do. Either you can use Thrift. There are all sorts of protocols to make 2 foreign languages interoperate. It usually requires copying time because you have to copy from one world to another. But that's true with what is true is that Hack was designed to interoperate seamlessly with PHP. Outside of that world, well, it's not any better than, you know, making 2 random languages interoperate together, right? It's not any better.
All right, so I think we'll take a chance now to grab some coffee and refuel. We're going to come back in exactly 10 minutes, so that's 25 past 11, for Josh's session on conversion. Thanks, everyone.
Thanks. Thanks.